In this case, what we want to do is look at the idea of finding the general solution to an inverse tan function, for a tan equation. So tan of theta is equal to root 3. So again, like we've done before, we want to work out, well, what's our related angle? This time, inverse tan of root 3 is going to be pi on 3. So that's our related angle to work with. And we also want to look at, well, where's tan positive? We know tan's positive in the first quadrant and the third quadrant. So what we need to do in this one is have a look at what pattern is going to be involved. The pattern here is to make sure that we get to an axis, the x-axis, and then add our related angle. Every time we're just going to an axis and then adding our related angle each time. So how do we remember how we get to the x-axis? It's just to multiply it by pi by k. So every time you multiply just a whole number by pi, that's going to put you on either the positive or negative x-axis. So if it's an even number, you're on the positive axis. If it's a negative number, it's an even number on the positive x-axis. If it's an odd number, sorry, we're on the negative x-axis. So whether it's an even number or an odd number, we're still going to add that related angle. So we're just going to make sure we get to an angle, get to an axis there by multiplying pi by some number, whether it's positive or negative. It's okay, because if it's negative, we're just going in the other direction. But it would still be negative 1 times pi gives us, and then adding pi on 3, and then we add that related angle every time. So in a general sense, what we're looking at is if tan of our theta is equal to A, then theta would equal inverse tan of A, because that's going to be our related angle of theta every time. So we're just going to make sure we get to our first and third quadrants by just multiplying by k times pi to put us on the axis, and then adding the related angle each time, and that will make sure we get into those quadrants.